Hi, welcome back. So this week we are going to talk about two main chapters on the relief systems. One is basically the introductions to relief, and then we talk about relief sizing. Relief sizing has more calculations in here. But our main focus will be the intro to relief, like what is relief system? Even though there are many safety precautions within a chemical plant, equipment failures or operator errors can cause increase in process pressure beyond a safe level. If the pressures goes too high, they may exceed the maximum strength of pipeline and vessels, and this can result in rupturings of the process equipment, causes major release of toxic or flammable chemical. So to resolve this, we want to first, what we call the inherent safety, is the first line of defense to prevent the pressure buildup. A second line of defense is to have a better control of the process. And of course, the third line of defense is where we install a pressure relief system. Pressure release systems are required for the following reasons. First, and that is the most important one, is to protect people from the dangers of overpressurizing equipment. And subsequently, of course, we want to reduce chemical losses during any pressure upset and to prevent damage to equipment or the properties. And if we can prevent all this, the next thing is it will actually reduce our insurance premiums. And with all this in, now one of the most important thing is to comply with the government regulations that what we need to do, what we can do, and what we cannot do. And having a good relief system is part of the regulation. The method used for safe installations of pressure relief devices is being illustrated in these slides. The first step in the procedures is to specify where the relief devices must be installed. So the guidelines are available, and we are going to talk more about the guideline, where can we do it in the next few slides as well. Second, the appropriate relief type must be selected. So the types depends mostly on the nature of the material relief and the relief characteristic required. Third, the scenarios are developed that describe various ways in the reliefs that can occur. The motivations is to determine the material loss mass flow rate through the reliefs and the physical states of the material, be it a liquid phase, vapor, or two-phase system. And next is to collect data on the relief process, including physical properties of the ejected material and the relief's size. Finally, the worst case scenario is selected and the final relief design is achieved. Every step in this method is critical to the development of a safe design. An error in any steps of this procedure can result in a catastrophic failure. Typical relief versus time curve for a runaway reactions is being shown in this figure 9.2 here. The assumptions made is that this is an exothermic reactions that occur within a closed reactor. And if the cooling is lost because of loss of cooling water supply or failure of valves or other scenario, then the reactor temperatures will rise. So let me just show it here, meaning here over time it will just go up, it will just rise. And the pressures within the reactor increase because the increased vapor pressures of the liquid components and gaseous decompositions product results in the high temperature. So if it continue to go up all the way up, and if we do not have any relief systems, and if let's say we continue to have input, meaning the incoming material is not being stopped, so what will happen is that it will reach a certain point that this whole thing will just collapse. However, if let's say assuming that the input is off, meaning we do not have any extra input, so what happened is that the pressure and temperature will continue to rise, If it's closed reactor, let me draw this out. So it will continue to rise, and without relief system, what happens is when the chemicals are all being reacted, so meaning there's no more chemicals can be reacted, so what happened is that it will slowly then come back down. It will slowly come back down. However, if we have a relief valve installed, in this case, so we look at all vapors. So then when we have a relief valve means we set a relief opening pressure. So the chemicals will go up, hit this line, it will open, so the pressure will release. And then when it come back down, then the valve will close back, so the pressures drop and it will start to build up back. And the moment it hit this line, this particular red line here, it will continue to just run in such a way. So you don't have a sudden release, or you don't have to wait until the chemicals being fully closed. And also, the moment we have this relief relief systems in place, we will also get to know that there is something wrong with our system. However, if we have a device, a relief device, okay, and that is a two-phase system, but it's a one-time use relief device, meaning what we had here just now that we talk about this one, this particular one is perhaps a spring system. So if we have a one-time use system, so one use system, so what happened is that we may have set the relief opening at a higher pressure. So this is where you have increase of pressure, and when it hits certain pressures usage of the one-time use relief valve, it will burst open and all your chemicals will then be released and it come back down. Even in relief system itself, there are two types of different valves. One is what we call pressure relief valve. Another one is what we call pressure safety valve. So they are basically different valves. So relief valve is where it has gradually open and closed, like the one that I showed to you earlier, the curve A, where you can see the curves, it will slowly go up and then come down and go up and come down. So it basically open and close according to what is your set pressure, what is your set the pressure that you set for your relief system. Okay, so the safety valve is more on when there is a spontaneous incidents where suddenly there's an outburst, sudden increase in pressure. So you want to let it release immediately. So meaning we don't have the luxury to go up and down anymore, because the pressure is going so high up. So you want it to just burst open. So normally in this case we use a one-time use valve. So the moment this valve give way, so it open up, and the chemicals will then be immediately released, and there will not be any closures for this safety valves here. So that is for safety purposes. Relief valve is mainly for us to save chemicals. Definitions that are commonly used within the chemical industry are being given in here in the next few slides here. So you have to understand what is things like, for example, set pressure. Set pressure means the pressures where we set when it reaches this pressure, the relief device will start to be activated. And what is design pressures, what is operating pressure? Do take notes that design pressures are not operating pressure. They are two different things. Operating pressure is our standard SOC, the standard operating conditions. Like if you want A and B mix to have a reactions, you need to run it at, for example, 400 degrees Celsius, 20 bar. That is the operating pressure. So if you have a vessels, you have conditions that you need to run the process at 20 bar, you cannot design your vessel to withstand only 20 bar. It has to be way, way, way higher than 20 bars. Okay, so and the differences between maximum allowable working pressure. So most of the time, this is higher than your SOC, meaning higher than the operating pressure. So gentle, just simple rule of thumbs, we normally use 20% to 30% higher of maximum allowable working pressure is about 20 to 30% higher than your standard SOC. Okay, and you can see that your vessel start to deform around 2 times of this. So meaning your design pressure will definitely higher than this. So this is where this value most likely will be your design pressure. And we talked about what accumulation is, means your accumulated pressures within the vessels. What is overpressure and what is back pressure? Back pressure means if we have a system, this is supposed to come in here and this is in, this is out. But however, because this equipment 1, equipment 2. So if your equipment 2 pressure is higher and you do not have a valve here, you don't have this valve, so it, instead of going out from here, it push back the pressures. It push this back in here. This is what we call back pressure. And what is blow down? And of course, you need to know this is accumulated, maximum allowable accumulated pressure is different from maximum allowable working pressure, yeah? And then what is relief systems? Okay, let's take a look at this chart here. What we have here is, you can see this is where, just now when I say we have our normal operating pressure or maximum normal operating pressure. And then we have a maximum allowable working pressures in here. You can see the percentage or the gauge is way higher. And then maximum allowable accumulated pressure is here. Okay, for multiple valve installations over other than fire exposure, or sometimes we may even have a higher value in here. So basically this is for us to know what is the pressures that we talked about earlier. So the procedures for specifying the locations of relief system require the review of every unit operations in the process and of every process operating steps. So the SD engineers, we have to anticipate the potential problem that may result in increased pressure. So you can see from these pictures, you have all the small vessels, you have the pipes and all that. So we have to look at it one by one. And pressure relief devices are installed at every point identified as potential hazardous. That is, at points that upset conditions create pressures that may exceed the MAWP. So the type of questions we normally ask in this review process is what happens with the loss of cooling, heatings, and agitations? What happens if the process contaminated or have this mischarge of catalyst, of monomer, etc.? So as a simple guideline to specify any relief position is it has to install at any point identified as potential hazardous. Any upset conditions that create pressures more than maximum allowable working pressure. So simple rule of thumb, number 1 is all vessels need reliefs. So including your reactor, even your storage tank, any towels, any drums, they need relief system. All the block-in sections of the cool liquids line that are exposed to heat, such as sun. So when the moment it gets exposed to heat, because they are supposed to be cool, and it has immediate expansions the moment heat are being introduced. So all the cool liquid line needs a relief system. And every pump, compressors, turbines need relief system because this is where there will be a change of pressures. So in the event the change of pressure fail, then we need the relief system to release those excess pressure. And all the storage vessels need pressures and vacuum relief. So meaning storage is not just one way, it has to be two ways. So in the event if we have a vacuum, accidentally we have pumped up more chemicals, and then the vessel, instead of filling up with the incoming air or incoming inert gas was being blocked, we may have a negative pressure. So we call that a vacuum scenario. So all storage vessels need both pressure and vacuum reliefs to protect against pumping in or out of a blocked-in vessels or against the generations of vacuum by condensation. And all steam jackets are often rated for low pressure steam. So reliefs are installed in the jackets to prevent excessive steam pressures due to operator errors or the regulator's failure. So let's take a look at this example here. We have a polymerization reactor systems that you can see we have a cooling system. At the same time, you see this double line, this vessel here. You have steam and steam in, same line here, okay? And you have steam trap going out here. At the same time, you have, let me use a different color, cooling water in, go in here, go back to the same track, but it come out here. Okay, so please take notes that this is common because sometimes to start a reaction, we need to give it energy to start up the energy, to start up the reaction system. So reaction process, sorry. The moment the reaction has been started up, and if it is an exothermic reaction, meaning the reaction itself generates heat, what happens is that our temperature will go up. Okay, so temperatures then go up when the reaction started. Immediately when temperatures go up, this valve here will then close. So you can see over here, this valve will close, this out valve will close, and what will open is the cooling water will then go into the same line and come out using the same system. Okay, so these are the data given: adding monomers for 3 hours, stripping residues monomer vacuum valve, and blah blah blah. So look at the system. Where do we need relief system? Where do we need to put in the relief system? So I have a bigger one so that we can start drawing. So first rule of thumb is all vessels need relief system. So let's put in one relief system here. So this is one relief system. Another one, so we have one drum, one vessel here, another vessel is here. So this one also, we need a relief system. So all vessels need relief system, that's number one. Number two, so all pipe in cool lines need relief system. So let's take a look at the water cooling system. In this case, we can just put it here. So our cooling water in or our steam trap in, here we have relief system. Okay, so of course here we also need another relief system. Okay, and what else? Where else do we need relief system? And we need relief system for all the pump. Just now we say pump turbines need relief system, so we need one relief system in here. So here also we will need one relief system. Any other places that need relief system? I think that's about it. So we have relief systems for all vessels. We have relief system for all the cooling in water. And also we have relief system for all the pipes out. Do we have storage tank here? No, so we don't need that. Okay, so then you get the answers, a nicer answer. There are two types of relief devices. One is what we call the spring-operated valve. The other type is what we call a rupture disc valve. So spring-operated valve is a reusable valve, meaning you can use it because when the pressure is too high, the pressure go up. This whole thing will push it up because as with a set pressure here, so this seats will go up and your chemicals can then flow out. So when the pressures here, the P in your process system drop, this whole thing will come back down again. So this is a reusable draft. And rupture disc is a one-time use valve. So it consists of a very thin layer of metal in here. So this one, when the pressures is very high and it pushed through, what happens is this metal will burst and give way, and all the chemicals in your reactors or in your storage tank will just burst and being released. And it get released to whichever containment tanks that you have. So, of course, at certain situations we have to use spring-operated valve, and certain situations we have to use rupture disc. So even for spring-loaded pressure relief valve system itself, it has three subcategory types. One is what we call the relief valve, mainly used for liquid. The other one is what we call safety valve, mainly used for gases. And safety relief valve, because you can see relief is for liquid, safety is for gas. So safety relief system is for two-phase system for both liquid and gas services. As we mentioned, there are two types of relief valves. One is spring-loaded, so they have two different logo as well. So spring-loaded logo, you can see this symbolizes the spring. Okay, and so this is the piping in. This is where your vessel is, and this is where it will go to your containment actions plan. And the other one, this is the symbols for a rupture disc. So very simple, very straightforward. But at different scenarios, we use the system differently. When do we want to use rupture disc? When do you want to use spring-loaded? Is going to be explained in the slides itself. The first scenario we are going to look at is using a rupture disc in place. So this normally we use it for corrosive chemicals. And don't forget, comparing to the price of spring-loaded and rupture disc, because rupture disc is a one-time use disc, as it's a very simple design, so it's way cheaper. Okay, so if you're using for highly toxic materials or corrosive materials and you want it the moment it gets high pressures release, you want it to release it all, this is where we use one single rupture disc. There are times where we, instead of using one, we use two. Okay, so what happened in here when we have to use two rupture discs? So let me draw service one here, and then we have a second one here. We use it for chemicals that are highly corrosive, means high acidic chemicals that may, because rupture discs are made of metal plate, a very thin metal plate. So what happens is if you have fumes that is so corrosive that it may actually after a while causes pit hole in this metal plate. So in this case, this first valve has to be changed regularly. So to the extent that every 3 months you have to change it once, because then to protect your second rupture disc. The reason is so that when you really need to release it, you have a valve in function. And if you only have one valve like this, if you do not have this one, imagine you do not have a second valve here. So what happens is all this pit hole here may causes you to have loss of chemicals over your operations period. So in order to save chemicals, and for highly toxic chemicals, we often use two systems. So this is where highly toxic chemicals, or sorry, highly corrosive chemicals, we often use two rupture discs. So if it's just a normal corrosive materials or the toxic chemicals, then we use one. But it's a highly corrosive, meaning it will easily causes peak hole to your rupture to your disc plate. Then we have to use two, and the first one must be changed regularly. So this is part of the maintenance cost. So the third one is when do we want to use one spring loaded, as you can see from here, one spring loaded and one rupture disc. Okay, so this is where you use it for a chemicals that the process that are not too stable. Let me draw. When we have a process that often go up and down, meaning your pressures go up, go down, that is not very regular. So you do not want it to spoil your chemical, your rupture disc. So what happened here is we use a spring loaded for expensive chemicals, and also whenever it has and process upset like this, the pressures go up, this will open up and then release pressure, and then it will close back, and it will again release pressure, and it will close back. Okay, so this guy is always in function because the process is unstable. However, if we have a major build-up, so this one go very high up, where this is because this is a smaller pipe most of the time, because you just want to release a little bit and then you want to close it back, so you wouldn't use a big valve here. But in the events that this process get extremely upset, that is danger now. This pipe size will not be able to cater for it, so you need a rupture disc that has a big piping system where this will burst and release all the chemicals so that you do not have a runaway system. Okay, so this is where you have to use both spring-loaded and also the rupture disc. But we have a unique scenario here. So when do we want to use two valves in series, one rupture disc and one spring-loaded? What happened here? So when do we want to use this? This is where you want to protect against toxicity when this chemicals is toxic, and also when you want the chemicals is expensive. So meaning when you have a relief burst, okay, you want it to be able to close back when the pressures drop. And also, if let's say this is also corrosive, you want to protect the spring here. You want to protect the spring here from the corrosive chemicals. That is where you use, again, this is as a protection, where you may want to change the valves regularly. Okay, so when you have a corrosive chemicals, yet expensive, and it is a toxic chemicals, this is where you want to use a rupture disc to protect a spring-loaded valve so that you don't waste chemicals, because the moment the pressures drop back down, it will close back. At the same time, you use the first layer of defense of your rupture disc to protect your spring-loaded disc. So what about cases, the number 5 cases where you have two rupture discs, but you rotate it? When do we want to use cases like this? This is another unique scenario where you have a drum, where you have an alternative valve. Okay, this is where you can either use here or you can either use here. You have two rupture discs here. This is to use when we have what we call a polymerization process, where periodically, if let's say for example you use valve 1 here, you notice that after a while you have a loss of polymer deposit here. In that case, this valve, the pressures, because this one become very thick compared to the original layer. So what happened is this pressure, in order to burst it, is increased. Your set pressure is no longer the set pressures that you want, but an increased pressure now. And so if let's say it reaches the set pressure that is supposed to burst, it will not burst because of the extra coating. So for polymerization process, we often use two rotating valves so that the first one, number 1, is in use. And when we notice there is all these deposits here, what we do is we switch to number 2. Then this one we send for maintenance or under cleaning. Okay, so that's where you rotate two valves, you clean them out, you clean them all the residues up, and then you put them back in use. So this is where you have to use two rotating rupture discs. This slide shows the advantages and disadvantages of various relief systems, such as your spring-loaded or rupture disc or your bucket pin. Bucket pin is very similar to rupture disc. It's also a one-time use relief system. One thing about the advantage of the spring-operated or spring-loaded is it is reliable. It can use in many services, and it can reset the pressures 4% below the set pressure, meaning it will stop releasing your chemical. But there's also disadvantages of the spring-loaded. One thing is affected by back pressure, meaning the moment you have a back pressure, your springs may be dislocated, and it also can chatter with high back pressures. And also another disadvantage is compared to other relief systems, spring operators are mostly more expensive. Rupture disc, in other words, is one thing good about it is it is very cheap. It's low cost, it's easy to replace, and it's good for high volume release, and it don't have any fouling or plugging. And it's also good for a second relief when you need it for a large area relief. But the disadvantages is that it is only one use, meaning it stays open after reliefs, and you can't test to see if that's functioning or not when of a burst pressure, meaning once it is used, it's done. You can't reuse it. And rupture disc often used for corrosive systems, so you need to have periodic replacement. And it, because the layers, the metal layer is very thin, it is sensitive to mechanical damage. So you have a knock or something, it is gone. Okay, so that's about the advantages and disadvantages. So with that, that's about it. Chapter 9, relief system. Introduction to relief system, and the next chapter is on relief sizings. I want you to do self-study because there's a lot of calculations in here. So look at the examples. How do we calculate it? You will not use relief size this chapter a lot. That is why I'm not going to go into detail about how to do the calculations. It's more of for your reference only. So in the event if one day you become the process design engineer, then you know where you can refer to chapter 10. It talks about how you calculate the calculations of the area needed for your relief valve. Thank you and have a nice day.